Let's have a look at question 2 of the November 2012 Edexcel P2 exam paper, measuring radioactivity. Scientist uses a Geiger counter to measure the radioactivity of a sample. She writes the results down in her notebook. The counter gives a rate of 120 counts per minute, and the average background count in her lab is 10 counts per minute. What should she write down for the count rate of this sample? Well, this is simply a case of the total count from the Geiger counter, which is 120 per minute, minus the background count rate that she's measured beforehand, which is 10. So 120 minus 10 makes the answer B, 110 counts per minute. Part 2 asks you to name one source of background radiation. Well, background radiation comes from the rocks in the earth in certain places. It comes from fallout from nuclear weapons explosions and tests. And it also comes from space as well as several other sources. But they're the main ones. Okay, explain why some people are exposed to more background radiation than others for 2 marks. Well, for this one, it's simply a case of saying that some people spend their lives in places where the background radiation is higher. Or for some reason they spend more time from their lives in places where the background radiation is higher. So for example, if you live in areas of Cornwall, radon gas from rocks leads to a higher background count rate, and if you live there, you're going to receive a higher dose over your lifetime. Likewise, if you live near the Chernobyl nuclear power station, where there was a disaster a couple of 20 or so years ago, then the background count rate is much higher and you're going to be exposed to more background radiation than others, or any other situation that follows a similar principle. Okay then, it now says the recommended safe limit for exposure to radiation has been reduced over the last 80 years. This is because now better instruments allow scientists to make more accurate measurements quickly. Could be, I suppose. B. Global warming has increased the rate of decay of radioactive materials. Well, that's just wrong. Humans release more radioactive materials into the environment. Well, they do, I guess, than they did 80 years ago. However, that's not going to actually change the safe limit. It's just going to mean you're going to reach that safe limit quicker. Oh, and then D. Scientists have a better understanding of the dangers of radiation. That's the correct answer, or certainly the most correct answer. We know a lot more about radiation now than we did 80 years ago when knowledge was in its infancy. Okay, B. After the accident at the Fukushima nuclear power plant in Japan, drinking water became contaminated with iodine-131. The graph shows how the activity of a sample of iodine-131 changes over 2 weeks. We've got activity in becquerel on the left-hand side and time in days on the bottom, on the x-axis. The half-life, I better read the question first. Use the graph to estimate the half-life of iodine-131. Show you're working clearly. Well, the half-life is simply the amount of time it takes for the activity of the radioactive sample to fall by half, and this number should be the same no matter which 2 values you choose. So you could go from 120 to 60, from 80 to 40, from 60 to 30, or any other doubling of activity numbers on the y-axis. But looking at the graph, it's far easier to choose 120 to 60 on this one. So I would write something like time for count rate to fall from 120 to 60, and then I'd use my graph read across on the scale here, and I can see that when the count rate is 60, starting off at 0 for 120, the time in days is 8 days, and that's the correct answer. Okay, it now says the recommended safe limit for a sample of this size is 100 becquerel. How long did it take for the activity of the sample to decay until it was below the safe limit? So we need to go back to the graph. I can see that it started off at 120, and for it to fall to 100 here, it looks to me like it's just over 2 days. But in fact, the mark scheme will allow anything from 2 to 2.5 days for the activity to fall below that safe level. And then finally, when iodine-131 decays, it emits beta radiation. And if you can't remember, beta is an electron, and it's the middleman as far as radioactivity is concerned in terms of damage and its penetrating ability. State one possible danger to health from exposure to beta radiation. So you could say that it causes DNA damage, you could say it causes cells to mutate, or ultimately it increases the risk of cancer in the future, or you could even say it causes cancer. I'm sure the mark scheme would be happy to accept that as well. And that makes question 2 complete.